In this video, we will use the negative binomial regression model to estimate the expected number of terror incidents for the province of Farah. We will calculate the variance of a negative binomial distribution that has this expected value and the value of theta estimated by the negative binomial regression model. We will compare to the variance of a Poisson distribution. First, we will import the libraries. So we will import statsmodels.api as SM. We will import pandas as PD. We will import numpy as NP. Then we will download the data. And when we look at the first 5 lines of the data, we see that Pashtun is with zeros, so it must be a categorical column. Let's look at the levels of this Pashtun column. So the data types of this data frame, we can see incidence, calories, Pashtun is of data type int 64, and population and troops are of data type float 64. We'll use the unique method to see the unique levels of Pashtun. So this is how we do that. So df of square bracket, the column name dot unique open and close bracket that prints 0 and 1. We will create and assign categorical object to the column Pashtun. So this is how we do that. We use the pandas library. pd.categorical bracket df square bracket Pashtun comma categories equal levels comma ordered equal false and print the data types. We can see that the data type of Pashtun column is changed to category. Then we will assuming df contains the data with columns. So the data frame contains the data contains calories, Pashtun, troops, and population along with incidence. So incidence will be our ndog. Ndog, this is our dependent variable, and independent variable will add a constant to it. So when we add the constant, and we'll create the data frame for calories, Pashtun, troops, and we will add a constant. That will be our exog, which is independent variable. Offset is np.log of df of column population. Then we will create the model and fit it. So this is how we do that. sm.glm bracket. So we'll put the formula over here, comma family equal sm.families.negative binomial, exog equal exog, offset equal offset, ndog equal ndog. When we print the summary of this fitted model, we can see that the number of the degrees of freedom for residual is 30. And what else is important here? Deviance, Pearson chi-square is 30.7. All of these are important, but let's go through the ones needed. So coefficients, we can see they are listed over here, and the important ones are the intercept, calories, Pashtun, and the troops. That is not so important with the p-value 0.474. Next, we will we already created this, so let's remove this. So when we look at the fitted values for Farah, we see it's 40.454191. The fitted value for Farah is approximately 40. Then we calculate theta estimated by the model. It is also called the dispersion. So this is how we do that. So the fitted model will take the Poisson underscore chi-square and will divide that by the degrees of freedom of the residue, and that gives the dispersion, the value of theta, which is 1.02 and so on. Then we will calculate the variance of this model. So dot fitted values of Farah plus we'll take the square. So we'll use the library np numpy dot square of these fitted values of Farah, and we'll divide this by the theta, the dispersion, and we'll add it to the fitted values for Farah. We have 1641.91 and so on has the variance. A negative binomial distribution with mean 40, that's the fitted value, and theta 1.02, which you calculated here, would have a variance of approximately 1642, which we calculated over here. Let's look at the Poisson model. We fit the Poisson model. So DF contains the data, calories, Pashtun troops, and population, and the incidence. And incidence will be the dependent variable, which is ndog, and exog, which is independent variable. We'll add a constant to this data frame, calories, Pashtun troops, and we will add a constant. And offset is numpy.log of df of population column. Create the model and fit. So this is how we do that. sm.glm of this formula, incidence equal calories plus Pashtun plus troops. Family is Poisson. Exog equal exog, offset equal offset, ndog equal ndog. So we fit the model, and when we print the summary, we see the degrees of freedom of the residual is 30. Poisson chi-square is 1.16 times 10 to power 3, so 1160. And these are the constants. We can see the p-values are very small, close to 0. So all of these independent variables are very important in this model. Fitted values for Farah, this is how we get it, like 62.96 and so on. Then we calculate theta estimated by the Poisson model, also called dispersion. Poisson underscore fit, that's the name of the fitted model, dot Poisson underscore chi-square 2 divided by Poisson underscore fit dot df underscore resid. So this is the degrees of freedom for residuals. Then we'll round that to the nearest decimal place and we'll print. So we got approximately 39. So theta, which is the dispersion, is approximately 39. Then we will calculate the variance of the Poisson model. And if we don't round that, it is 38.72 and so on. Calculate the variance of the Poisson model fit. So fitted values of Farah plus numpy square of these fitted values for Farah divided by the dispersion, the theta, which is 164.61. So a Poisson model with mean 63, So we can see the expected value is about 63 for Farah, would have a variance of 160 of approximately 165. So the negative binomial has a much larger variance. The negative binomial has a variance of 1642.